Alrighty, so we've been talking a lot about distributions and displays of different data sets, and now we're going to talk about how we describe those distributions. So when we're looking at describing our distributions, we're going to look at comparing and summarizing information displayed in graphs. So one thing to remember when you were describing a distribution is to remember your socks. So don't forget your socks. Think about if you are wearing shoes. If you forget socks, you have nasty, smelly feet. No one likes to be friends with you. Make sure you don't forget your socks. So the S is going to stand for your shape of your distribution. O is going to represent your outliers. C is going to represent your center. And S is going to represent your spread of your data. So you're going to look at your 4 different pieces. So we've talked about shape before, but we're just going to reiterate what all the different shapes are and what they look like with different displays. We talked about outliers, looking at visual outliers when we have like 90 and 95 and 80, and then we have a 0. Visually, we can see the 0 is going to be an outlier. It's something that's way out far, out and off into abyss, away from the data that is the normal data. And then we have the center. We have 3 measures of center: mean, median, and mode. Remember, we look at mean and median the most. Mode we don't really look at as much. And then we're going to take a look at the spread of the data. So the spread of the data is also going to be your 3 different measures of spread. We have our standard deviation, we have our IQR, and we have our range. And we'll talk about when to use each one here in a little bit. Now, the only time that we use socks is after we graph quantitative variables only, which just helps us identify patterns and answer questions that we may have about our data. Now, we do not use socks to describe categorical variables. Why? Once again, do not use to describe categorical variables. So think about it this way. We're describing what we see in our variables here in our data set, and when we're looking at the display of the distribution, whether it's a histogram, remember we use that for quantitative variables only, or stem plots, quantitative variables only. Think about the shape of the distribution. So let's just go through the socks. Shape of the distribution. Now, if I have the shape of my distribution, think of ice cream flavors, for instance. So if we're looking at ice cream flavors and I had mint, strawberry, chocolate, and vanilla, does it matter how I order those on my x-axis and how I organize those categories? No. I could put chocolate first if I wanted to, and then I could put mint first because I know that was my favorite. So maybe we just didn't do mint or vanilla. Maybe we did vanilla first. Our shape of our distribution is going to change depending on how we label our x-axis and where we put those categories. Outliers, maybe one person likes strawberry, maybe that's an outlier, but we really looked at center and spread. When we're looking at center and spread, those are numerical descriptions only. We can't find center and spread when we have a categorical variable. Remember, think back to our review from our quiz when we had all the different 1s and 2s on our data set, and the 1s represent males, 2 represent females. We found the median, but when we're looking at the median, which is our center, we just said the center was a male. How? That doesn't make sense. We can't find the median because they can order people however they want. That guy is going to change depending on where I put him as well. So center and spread are only used when we have numerical values and numerical descriptions. So something to note and write down. All right, we've talked about shapes before, and we're just going to talk about them again. So when we're looking at shapes, we talked about unimodal and how unimodal was one peak. Think uni means one, mode means, or modal means mode. So we got one peak. Now, sometimes we have it in the center where it goes up in the middle and goes back down. But other times we can have something on the side and the one peak on the left-hand side, and we have something like this. So just be aware that it doesn't always have to be in the center. Then we have bimodal. Think bi meaning two peaks. Sometimes we have the two peaks are the same. Other times they could be different. So I might have something like this, and it goes down and it goes back up again. Those are still bimodal because we got two different peaks going on. They don't have to be the same exact size. And remember, uniform, we talked about how it's going to be approximately the same value. All the way across. So when we're looking at this, we have like some type of uniform distribution where everything's almost the same. Maybe they're a little bit off here and there, but all around should be the same. All right, then we have symmetric. Usually we use one of these guys from our unimodal, bimodal, uniform, and then we use one of these guys to also describe. So usually we use two different words to describe the distribution. So when we talk about symmetric, we're going to talk about a mirror image here. Now, the easy one is when we go up in the middle and go back down, where it's kind of the same on either side. But we can have something where it kind of goes up and goes back down and the same, and it's still mirrored. Or what if we had a uniform distribution? Uniform can still be symmetric, where we have our uniform distribution and we split it down the middle and it's the same on either side. Or we might have none of these three, and we may have something that kind of goes up and comes back down and then goes back up again, and it's still symmetric on either side. So symmetric really just means it's a mirrored image on either side. Now remember, left skew versus right skew. So left skew is where your tail is on the left. So where we have our high values and our tail goes off into the left. So something like this. Right skew is where our tail is on the right. So where I have my hump on the left, or my peak on the left, and it drops off to the right-hand side. Now, we talked about different displays where we have histograms, we have stem plots, everything else. Now, this is called a density curve. This is like something I would like draw over top of my histogram or over top of my stem and leaf. Something to keep in mind when I talk about a density curve. That's what I mean. So once again, we can use one of two different, we can sometimes use one word, we can use two words. What I would like you to do is pause the video, and I want you to draw a symmetric bimodal distribution. So I want you to draw a symmetric bimodal distribution. Go ahead and pause it. When you have a symmetric bimodal distribution, we're going to want something that is mirrored image and also has two different peaks. So we could have something like this, where the peaks are the same and they're symmetric on both sides. So now I want you to try a unimodal right skewed distribution. Let's go ahead and give that a shot and pause the video. You should have something where we have a unimodal, so one peak, and it's right skewed, so our tail is going to go off to the right. So we should have something like this for our density curve. All right, so now let's talk about what does this look like in each of the displays that we've been talking about. So we talked about histograms, we talked about stem plots, we talked about dot plots, and we also talked about box plots. So when I have a symmetric uniform distribution, remember, usually uniform distributions are going to be symmetric because they're approximately the same on all the way through. So when we're looking at uniform, I'm going to have something like this, where maybe I have one that peaks a little bit higher, and then we got a little lower, higher, we got lower, all the way around. That'll be something that would be a uniform symmetric distribution, where you have something on either side that's exactly the same. Now, for our stem plot, remember we have our stems, so like 0, 1, 2, 3, and 4. And let's just say, if I have a uniform distribution, I'm going to have the same amount of leaves in each of my stems. So like, let's say I have 1, 2, 2, 4, and I have 1. So I have, remember, this is 11, 12, 14, 15. Maybe I have a 22, a 26, 2 27s. Maybe I have 131, 2 35s, and a 38. And maybe I have a 42. I'm just making this up. You can make whatever up you want. But remember, this is like sideways histogram where I can draw my bars and we can see that they have the same frequency in each piece. If we turn it sideways, we have my histogram here, which is very similar to what we have here. So looking at my dot plot, so remember dot plots, different than box plots. Some of you guys drew dot plots for your box plots on your last quiz. Make sure that when you have a dot plot, that we're going to have the same amount of dots. So dot plot has dots in it. Box plot is going to have a box in it where we have 2 dots on either side. So just beware of the difference between the two. Maybe I have like 3 dots here. I have 3 dots here. Maybe I have 4 here, but I have 3 and then 3 more. So it'll be something like a symmetric uniform distribution. Now, with my box plot, we're going to have an even quartiles. So when I say even quartiles, our whisker is going to be the same amount as our first half of our box, the same length as the second half of the box, and the same length as our whisker on the end. So I'm going to have everything be like equal length here. So I have that's my first quartile, second quartile, third, and then same even quartiles across. Where we have our median right in the middle. Alrighty, so symmetric bimodal. Think of symmetric bimodal. We're going to have the same exact thing on either side where we have 2 peaks. So when we're looking at our histogram, remember, make sure that your bars are touching. I know mine up here are not touching, but that's we're just drawing it weird. So maybe I start off with something that is tiny, and then I go ahead and I move up, and then maybe I come back down here, and then I go back down to like a little guy. We move up again. We go back up to our same peak, and then let's say we go back down again. So we have a bimodal symmetric distribution where I can draw my line down the middle and it's symmetric on either side. When we have our stem and leaf plot, make sure that we are going to have 2 modes. So let's just say I have like a 2 and a 6 here. Let's say, so we're having like something that's tiny, and then I'm going to have like a large mode here in my 10s. And let's say I have a small number, and then I'll have a lot of 30s, and then maybe I have like a few 40s. So maybe I have 3 13s, a 15, and a 16. And then maybe I have just a 25 here, and maybe I have a 4, a 35, another 35, and let's say I have a 38, something like that. And then I have like 2 49s or something. So once again, you can draw your boxes around here, and you can kind of see what your histogram would look like when you're looking at sideways. You can now kind of see that it's bimodal distribution there. All right, when you're looking at your dot plot, so let's make sure that we have maybe 2 here. We're going to have a high peak here. Maybe we go something low on the low end, and we come here, and we have just 1 in the middle, and then it's going to come back up again, and it's going to go back down. So bimodal distribution there. Now, when we have our box plot, we're going to have short little whiskers on either side with a long box in the middle. So we're going to have short little whiskers on the side. If you want to put short whiskers, that works too. All right, unimodal left skewed. So unimodal meaning we have one mode, so one peak, and we're going to have our left skew, meaning our tail is going to go off to the left, meaning that we are going to have high x values and also mixed with our low x values. So we're going to start low and we're going to climb up to a higher value here. So let's say we have low x and we keep going and we keep building and we keep building, say we build, and then let's say we just drop off right here. Still, when we draw our density curve, we can see our tails going off and to the left. So when we're making our stem and leaf, we want to make sure that we have only a few low x values, but we're going to have a lot of high x values. So let's say that we just have 4 here and maybe 16 and maybe 25, 26, and 27. And then we're just going to build. So we have 30, maybe 2 32s, a 35, a 36, and a 37. And maybe we have a 41 and a 42. So once again, if you want to draw your boxes around your values here, you can look at it sideways. We know this is going to be left skew. Alrighty. And always make sure this is like your x-axis when you turn it, because sometimes we have that back-to-back stem and leaf. Alright, so for my dot plot, we're going to have something that is going to be building up in our dots. So we'll have maybe 1 here, maybe we have 2, and then we build up to 3. And let's say we build to 4, and then we have maybe 5, and then we drop off. So looking here, we're just building and having that density curve over top of it. We can see that the tail goes off to the left. Now, when we have our left skew, think about our minimum value is going to be all the way down here. And a majority of our numbers are going to be up here in the higher values. So when we draw our minimum is being stretched. So our first quartile is being stretched because we have our minimum value over here. So we're going to have a really long left whisker. And then we'll have our box over here on the right, because that's where majority of our values are. And then a small right whisker. So if you want to put long left whisker, just to remind yourself, that's what it's going to look like. All right, vice versa for your right skew distribution. For your right skew distribution, we're going to start on a high value, so a lot of our high values, and we're going to decrease to, a lot of low values, and we're going to decrease as we get further down to our high values. So we're going to have some peaks over here on the left, and let's just say we decrease over here to the right. So we should have our tail going off to the right when we draw our distribution off to the side. So when we have our unimodal right skew distribution for our stem and leaf, we're going to have a lot of low values for our x and then only some high values. So let's just say we have like 3 zeros and we have a 1, a 2, a 6, a 7, and then maybe we have a 10, a 12, a 13, and a 15, and then maybe we have 2 22s, and maybe have a 31. Let's throw a 24 in there. Maybe we have a 31 and 32 in there, and then we have like a 40. So this would be a right skewed distribution here. And you can turn your paper off to the side. You can draw your little boxes to make your histogram if you want to do that. And you can see that we have that right skewed distribution there. Alrighty, so now taking a look at a dot plot, same thing. We're going to start off with a lot of our peak over here on the left, and we're going to taper off to the right. So we got 1, 2, 3, 4, 5. So let's just say we start really high, and we go kind of just down from there. Now, much like our long left whisker for our left skewed, we're going to have a long right whisker because our values are getting, our maximum is getting stretched up, because remember that's what our dots mean. So our maximum is getting stretched up all the way up here where we have our quartile, our third quartile is being stretched a little bit. So we're going to have a small little left whisker, we're going to have our box over here, wherever our median may be, and we're going to have a long right whisker. All right, the last one is called a multimodal distribution. When I say multimodal, it just means that there's no really great pattern to it. So if I take a look at something that would be multimodal, I would want something that's going to go up like this, and then maybe it's going to go down, and then maybe we're going to have something that's a high peak again, and then maybe it goes back down, and we get something like this, and it peaks again, and then we got something that like tapers off. There's no real great pattern to it. It's not going to be left skewed, it's not going to be right skewed, it's not uniform, everything's just kind of everywhere. So when we're taking a look at our stem and leaf, we're just going to make sure that we have multi-modes. So different, multiple peaks that we're going to be looking at. So let's say I have 2 5s and a 9. Maybe I have a 16, a 20, a 21, a 22, a 24. So we go up a little bit. Then we're going to go back down. So like a 37 and 38. And then maybe we have 2 40s and a 36, or sorry, a 43, and let's say we have a 46 and a 47. So something else like that. We have lots of different modes that are going to be involved. Looking at a dot plot, 1, 2, 3, 4, 5. We're just going to have, once again, multi-modes. So let's say I have like 1 dot here. Let's say I'm going to have 3 dots on this guy. Maybe then I have 1, and then I have 2, and then I have 3 again. So it's just going up and down and fluctuating accordingly. Now, this is going to be very similar to our bimodal distribution. So when we talk about bimodal, we might be looking at something like really short whiskers and then a long box on either side. So it's very similar to our bimodal. All right, so we've talked about shape, covered shape with all the different displays that we've looked at. So we have socks. S is shape. O is now outliers. So we talked about 2 different ways to measure our outliers. One way to measure our outliers is just visually. So remember where we had the 98, the 99, and then we had the 80s, but then we also commented on, well, we had a 0, and it's going to be a visual outlier there. Or we can see that 1.5 times our IQR rule. And we're only going to use this if we have exact data. So if we have exact data, or if we have the 5-number summary, so we can use our quartiles to help us find our IQR, and then do 1.5 times our IQR, add it to my quarter 3, or my Q3, or subtract it off of my Q1, then we can get our outliers here. Our mean is non-resistant to our outliers. Remember, it just can't resist the fact that there are outliers. It's going to get changed. So we have our shape, we have our outliers, and now we're looking at our center. We had 2 different types of center that we usually use. We use mean, which is non-resistant to outliers. Then we use median, which is resistant to outliers. Now, if you suspect outliers in your data set, so visually you can see outliers, or you determined one from the IQR rule, you're going to make sure that you use median to describe the center. Otherwise, you're going to use the mean for the center. Now, we don't use mode very often. The only time you can use mode is if it's in the center of the data. So when you have your center of your data, usually you have like a symmetric data set where we have something that's going to look like this, where it goes up in the middle, goes back down, right? Where we have our center. Our center is going to be our mode, because it's the most frequent number. Our median is probably going to be pretty much the same as our mean. Everything's kind of in the middle. It tapers off in the middle or off to the side. So I can say that my mean is going to be approximately the same as my median, which is pretty much the same as your mode. And that's really the only time you're going to use mode, because that's when it's in the center of the data set. You know that it's going to be roughly equivalent to the other two. Now, if we have a skewed distribution, doesn't mean that we always have outliers. However, we do have values that are pulling our mean towards that tail of the distribution, meaning our median for our skewed distributions is going to be a better bet, a better indicator for our center than a mean. And the reason why is if I have a left skewed data set, so remember we have our peak over here to the left, or our tail off to the left, and we have a peak on the right. If I'm looking at my peak, that's where my mode's going to be, right? My mode is going to be right here, right in the peak. But if we're looking at my median might be a little slightly lower, just because when we're looking at the values and trying to find the middle of the data, maybe we have some values over here and no values over here, but maybe we have still some values that are going to pull that down a little bit. So my median is going to be slightly less than my mode. So let's say here's my median here. But the one that's going to be drastically affected by these low values is going to be my mean. My mean is going to get pulled towards that tail even more than my median. So here is going to be my mean. Now, if we're looking at my mean right here, my mean is going to be my lowest value of between the two of my measures of center. So when we're comparing the three, my mean is going to be my lowest, which is going to be less than my median. And my mode is going to be my highest number here. That's why looking at the middle, my mean is going to be the lowest. My highest is going to be my mode. The middle value in the center should be my median. That's why we're going to use our median when we have any type of skewed distribution. Doesn't necessarily mean we have outliers, but it does mean that we have low values, that it's going to pull that mean, or it's going to make that mode high because we have a skewed distribution. And vice versa if we have a right distribution. I have my peak off to the left, tail off to the right. My mode is going to be right where my highest value is. So here's my mode, which is going to be my low value here, because these are my low x values. We have a lot of low x and only some high x values. My median may get pulled up a little bit. Because depending on how many values we have over here. But this will probably be my median. However, my mean is going to get pulled up even more so than my median, because we're going to have these high values that are going to pull that towards that tail of my right skewed distribution. So my mean is going to be my highest value here, then my median, and then my mode. So my mean is actually going to be greater than my median, which is then greater than my mode. My mode is my lowest number here. So this value is too low for my center. This value is too high for my center. Median is going to be right in the middle, which is a good indication of the center, because this one gets kind of put up wherever our peak is, which is going to be on the left. And then we're going to have this guy that's getting pulled up high due to my right values and my high x values here. Okay, so we have shape, we have our outliers, we have our center, and the last one's going to be our spread of our data set. So when we're looking at the spread of the data set, we are going to look at three different values. Remember, we have range, IQR, and standard deviation. If we ever have our mean of our data set in the center, meaning we have no outliers, remember, the measure of spread that uses mean in the actual calculation is standard deviation. So we're going to comment on standard deviation. They go hand in hand. So we have mean and standard deviation. So mean for the center, standard deviation for the spread. If I use median for my center. I'm then going to use my IQR for my spread. Now, the only time we use a range is if we don't have data to find the standard deviation or IQR. We're going to comment on the range. So if we don't have any type of data set to find the standard deviation or IQR, you're going to comment on your range. And there are our SOCs. We have our shape, all the different ways to describe our shape. We have our outliers, so visually, and then also looking at the IQR rule. And then we have our center, which are mean or median. And then we're looking at our spread, which is standard deviation or IQR, depending on which one we talked about with center. So now we're going to discuss the length of words in the songs that are named here. And we're going to create histograms of each data set. And I'm going to ask you to pause the video and actually create your histograms. And then we'll come back, and that way you can kind of see what the histograms look like. So first of all, this means that there were 9 words with 1 letter in them. There were 109 words with 2 letters in them. There were 42 words with 3 letters, 51 words with 4 letters, so on and so forth. So we're looking at Sweet Child of Mine and Butter by BTS. Creating histograms. Remember, our histograms make sure that our boxes touch. So making sure that our boxes or our bars touch, and making sure that we have even increments and even intervals and even bins throughout. So we got to figure out our bin value. Now, if I take 10 minus 1 and we divide it by 5, I'm going to take 9 divided by 5, I get 1.8. So we'll take roughly 2. Now, if you break this up into 2s, right, remember, I want to make sure that I don't include the letter 2, because I'm going to go from, if I start at 1, then I'm going to have up to 3, and then I'm going to have 3 up to 5, so on and so forth. So I'm going to go ahead and I'm just going to divvy this up so that way I have these bars here. And that way my 10 goes all the way up, and we're going to include that bin at the second. So we actually have like 6 bins, but whatever. It's okay. So I'm going to have 0 up until 2. And then I'm going to have my bin 2, because I'm counting by 4s. I'm just going to start at 0 because it's easier. So 0 plus 2 gives me 2. 2 plus 4, 2 plus 2 gives me 4. Then we're going to have 4 up until 6. 6 up until 8. 8 up until 10. 10 up until 12. And we're going to do the same thing over here, so we have the same bin sizes. And that way we can easily compare the two. All right, so what we're going to do is create 2 different histograms. So the first one will be Sweet Child of Mine. So we'll have Sweet Child of Mine over here. And we'll have Butter over here. And we're going to make an X and Y axis. So we have my Y axis and my X. So looking here, we have my bins. So this is going to be the length of words. So we'll have my values length of words. And we have 0, 2, 4, 6, 8, 10, 12. My bin sizes. And I got to figure out what my frequency is going to be. So I got to figure out what my largest value that I need to go up by is. Largest value is 109 plus 42. That's going to get me 151. This one's going to get me 98. So 151 is going to be the highest that I have to go to. So we can count by tens, and we can kind of go up evenly in even increments by tens all the way up to 160. So I have 10, 20, 30, 40, 50, 60, 70, 90, 100, 10, 20, 30, 50, 60. I'm just going to label every other. So I got 20, 40, 60. The 80 needs to be a little bit lower. 80, 100, 20, 40, 160. That way it's not as cluttered. All right, so I'm going to do the same thing for butter. So looking at butter, we'll have our y and our x-axis. We're still going to have bins and length of word, or word length, whatever you want to put there. So we have 2, 4, 6, 8, 10, 12. We're going to have my frequency over here. All right, so I got to figure out how much we're going to go up by for butter. So looking here, we have 168, 137 plus 36 is going to give me 173. So we're going to make sure that we have going up to 180 at least. So we can still go up by tens, and then we're just going to go a little bit higher, and that's okay. You can go back to 200 if you wanted to. It's really up to you. So let's see, we got 10, 20, 30, 100. All right. So we got 20, 40, 60, 80, 100, 20, 40. All right. So now what I want you to do is actually fill in your bars. So go ahead and pause the video and go ahead and do that. Draw your bars. All right, when you do so, you should get some bars that look like this. So that was our first question, was to draw or create some histograms. So looking at the second question, it's talking about comparing. So when you say compare the shapes of the distributions, we're going to make sure that we actually take a look at comparative language when we're looking at this too. So comparing the two different shapes, we want to take a look at the shape of the distribution itself. So when we're looking at this, both of them are skewed right, and both are unimodal. We might have one mode because this one's going to be a little bit higher than the other. So we can say both distributions are right skewed and unimodal. Okay. Third question is, what are the medians of each data set? So if I want to find the median of each data set, I want to find the middle value. And we talked about doing this in the past. So something that we probably want to take a look at is how many total words are in my data set. So if I want to take a look, if I take 9, 109 plus 42 plus 51 plus 47 plus 2 plus 6 plus 2 plus 1 plus 1, I believe we get 270 words. So if there are 270 words, remember the median is halfway in between. So if I take 270 and divide it by 2, I'm going to get, 135 words, meaning I want the 135th word in my data set. We're just going to take a look at this data set here. I want the 135th word from the start, so from the top of my distribution, and we're going to count to 135. So let's see here. This is 118, and then when we get here, we'll get to 160-ish. So our median is going to lie right in our 3 letters. So we can say that the median, so Sweet Child of Mine's median is 3 letters And then it says find the median of the other data set. So we can say Sweet Child of Mine, median is 3 letters, not 30. Now we're going to take a look and do the same thing. So we're going to find the total amount of words. So if we take 13 plus 77 plus 91 plus 137 plus 36 plus 26 plus another 9 and another 3, we should get 392 words. And we're going to find the middle of that because that's going to be 50% of our data. That's where we want it to lie. So if I take 392 and divide it by 2, I should get 196. So I want the 196th-ish word. Where does that fall? What bin does it fall into? What letter does it fall on? So I'm going to take a look. Let's see here. We got all the way up to, if I take 13 plus 77 plus 91, I get 181. So here's 181 right here, because it's 168 plus 13. And I want the 196th word. So we're probably looking at, we're not going to get out of that 4, because we only have, out of that 181 left over, we only have 15 more. So we're going to be right in that 4-letter range. So we can say that Sweet Child of Mine's median, median is 3 letters. Butter's median is 4 letters. So we have a slightly higher median for Butter than we do for Sweet Child of Mine. Now, looking at our question 4, it says, where do you estimate the mean to be for each data set? Higher, lower, or approximately the same as the median? So looking at my question 4, my mean will probably be higher than my median. So my median's going to be right in here. Median's going to be right in here. My mean is probably going to be higher than my median because we have, especially in Butter, because we have a lot more 5s and 6-letter words. And then we also have these 10-letter words that are going to pull that median up in both cases. So our mean is probably going to be higher than the median, strictly because we have larger values in each data set. All right, last question. So our last question says, what is the range of each data set? So looking at the range of each data set, if we're looking at the range of each data set, I can take my high value minus my low. Now, if we're looking at my histogram, I could take 12 minus 0 and I get 12. If I'm taking a look at my actual values, I can take 10 minus 1, which is going to give me 9. So my range of the data set is 9 letters, which is the same. Now, why is this not a good estimate of spread? Well, it's not a good estimate of spread because our large values and low values are the defining factors of range. So it's something that you should say right here. We have no, it's not a good measure of spread, or not a good estimate of spread, because the extreme values, or my high values and my low values, are what define the range. And that's it. So just make sure that you grab your worksheet from me and start working on that. Your histograms are already kind of spread out for you, and kind of your tables are already made for you, so that way you don't have to create all the different bin sizes. All you have to do is count them. And then you also have another question about 2 different box plots.